Hello everyone and welcome to this explanation for worksheet 2B. This is in week 4 of the year-long college algebra class. So looking at the scope in week 4, we did worksheets 2A and in-class day 1 for week 3, so you should have those done or close to done already. This week we didn't have any school on Monday because of Labor Day. So the worksheets that we're going to be doing this week are 2B, 2C, and then 2D is going to be the review. There is going to be a second quiz in this week, and I will let you know on how to take that quiz. It's probably going to be in person, so when you see me this week, we'll probably do some stuff in class, and then we're going to take a quiz. So let's talk about worksheet 2B. Okay, on this worksheet, looking at number 3, this worksheet is kind of a review or a rehash of factoring. If you struggle with factoring or you don't remember how to do it at all, this is something that you're definitely going to want to revisit with other videos on how it's done. I'll put up some links for Khan Academy videos or tutorials on how to factor, but this is basically what this worksheet's talking about. So looking at number 3, we have all of these things are divisible by 6. So at the very beginning of the problem, if you don't want to deal with really big numbers, you can factor out anything that they have in common. So I factored out a 6. 6 goes out front, and I have it in red here. And now I'm going to kind of ignore that 6 all the way until the end of the problem because I need to factor out what's left inside the parentheses. So inside the parentheses, I'm going to multiply x squared times negative 20, and that's how I get the top of this x problem or diamond problem. So I get negative 20x squared up top, and then the negative 8x goes on bottom. Now, what we're looking to do is replace that negative 8x in the middle with two things that are going to be just more helpful, okay? So in this diamond problem, I'm looking for two things that multiply to make negative 20x squared, and they have to add up to negative 8. Well, the two things that I found were 2x and negative 10x because they add up to negative 8, and they multiply to make negative 20. So over here to the right, I am going to replace negative 8x with 2x and negative 10x. Then I just put parentheses in there, and the one thing you really need to pay attention to in there is when you put the parentheses in there, make sure there's a plus sign between that 2x and that negative 10x. So the negative kind of gets assigned to the negative 10x. So then I just factor out what's common in each of those parentheses separately. So in the first one, both of those have an x, so that's how I get the x out front. The second set of parentheses, both of those have a negative, and 10 goes into both of those, so I pull out a negative 10. And then both of those parentheses are x plus 2, so if those don't match, you did something wrong. So I write x plus 2 on the bottom, and then in front of it, we have an x, and the other one's minus 10, so we just call that x minus 10, and that's my other set of parentheses. And then the 6 that I pulled out at the very beginning has to drop all the way down, and now goes in front of this new stuff. So that is that problem completely factored out, okay? Number 5. Number 5 doesn't have a middle term, so there's no just regular x on this. So this is going to be that special situation where the middle term cancels off. And if you can memorize how this works, it'll save you a boatload of time on these worksheets. If you don't know how it works, let me show you. So 9 and 16, I multiply those together and I get 144. And I put the x squared on them, and it is negative because the 16 is negative. Now the middle term is not there, so there's nothing with just a regular x on it. So I put a 0 on bottom because it just doesn't exist. So now, two things that multiply to make negative 144 that add up to 0. Well, those are 12 and negative 12, and that's how I got the stuff in blue. And then I rewrite my original equation with these two things in the middle. And if you notice, if you add 12 and negative 12 together, they would cancel off, and we would have what we started with, so it works. Introduce the parentheses and make sure that negative gets assigned to the negative 12x on the right side. Factor out what I can. The first set of parentheses has a 3x. The second set of parentheses has a negative 4 in both of those, so I factor that out. Inside of both of those parentheses, I have 3x plus 4, so that becomes my one of them. And then the other one, I have a 3x in front of the first set and a negative 4 in front of the second set. So I have 3x minus 4 times 3x plus 4. And this is why the middle term cancels off. So if you can remember this, they're called conjugates of each other. 3x minus 4 and 3x plus 4. One's positive, one's negative, and that's how you get that middle term to cancel off. The other thing you might notice is that if you square 3, you get a 9, and that's what we started with. If you square an x, you get x squared. That's what we started with. And then if you square 4, you get 16. The only thing you have to keep straight is that minus in between, and that's how you'll get it, okay? Number 6. So number 6 is tricky because it's a fraction, and then there's going to be some factoring within the fraction. When you're all done factoring everything, a bunch of stuff's probably going to cancel off on most of these problems. So if nothing's canceling off, it might just be kind of a weird problem, but almost every problem has something that cancels off. So looking at number 6, I look at the top first, and I'm going to factor this. Multiply 2x squared times negative 4, and I get negative 8x squared up top. And then the middle term is a 7x, so that goes on bottom. And I'm looking for two things that multiply to make negative 8 that add up to a positive 7. Well, those two things are 8x and negative 1x, and that's what I got here in black. Now, those two replace 7x in the middle. And now I just introduce parentheses like I did here, and just be careful of that negative in front of the 1. And then on the first set of parentheses, I factor out a 2x. Second set of parentheses, I factor out a negative 1. And both of them, both parentheses now are x plus 4. And if, like I said, if they don't match, you're not doing it right. So you got to go back and find your mistake. So x plus 4 goes on the right side. And then the 2x and the minus 1 were in front of the parentheses, so they become my other set of parentheses. Now this is the top, and this is in red. Okay, let's look at the bottom. Well, on the bottom, both of those, it doesn't have a constant term, so I'm just going to factor out what I can out of both of these. Well, both of them have an x in them for sure, and then both of them have a 5. So I'm going to factor out a 5x out of both of those, and you're left with just 5x times x plus 4 in parentheses. So I put that on bottom in blue. I put the other one we did in red on top, and both of them have an x plus 4, and everything's multiplying, so you're just going to cancel those off. And you're just going to be left with 2x minus 1 divided by 5x. That is done. Okay. Let's look at number 10. Number 10 is a lot more involved problem. We have a fraction, and it's dividing another fraction. So a lot of stuff is going to have to factor here, and I'm not showing all of my steps for factoring like I did on the previous ones. So here we go. So the top of the left fraction is going to factor into 3x minus 1 and x plus 4. The bottom of it, it doesn't have a constant term, so we just pull out as much as we can out of each of those. So they both have at least 2 x's in them, and they both have an 8 in them. So I pull out an 8x squared, and I'm left with a 3x minus 1. So in this left fraction, you could cancel off the 3x minus 1, and we are going to do that eventually, but we're going to leave it for now. And that is being divided by, well, on this fraction, on the top, both those have a 9. I pull that out. On the bottom, both of those have a 12 and at least 3 x's to pull out. So I pull that out front, and this is what I'm left with. I do keep, change, flip. So I keep the first fraction the same, change it to multiplication, and then flip the other one upside down. Okay, and then a bunch of stuff is going to cancel here. So anytime I have the same thing on top and bottom, I'm just going to cancel. So 3x minus 1 and 3x minus 1, they cancel off in red here. X plus 4 and x plus 4, those cancel off here in blue. And now other stuff is going to cancel, but here I'm going to kind of put stuff together. So up top, I have 12x cubed, so I wrote 12 times x times x times x, and then the 2x minus 3 I just put in parentheses. Over on the bottom side, I have 8 times 9, and then I have a couple x's. Well, those couple x's are going to cancel each other off, so I'm only going to have a single x up top. 12 divided by 72. Well, if you do 72 divided by 12, you get 6. So it's going to reduce down to 1/6. So up top, I didn't write the 1 in front of that x, but there's really 1 there. So we have x on top times that 2x minus 3, and on the bottom we just have a 6, and that is the entire problem. Okay, pretty tricky. All right, let's look at number 13. Number 13 is one of those ones where you have two fractions being subtracted, so you have to make the bottoms the same. So we're going to have to multiply by some binomials in order to make this happen. So the left fraction, I'm going to do 1 over x plus 1. I'm going to multiply this by x plus 2 and x plus 2. Now, the reason you're allowed to do that is because x plus 2 divided by x plus 2 is just 1, and multiplying anything by 1 is fine because you're just left with the same thing. So if I do that, you're going to end up with x plus 2 up top. And then on the bottom, I'm not going to FOIL that all out unless I absolutely have to, and I don't have to here. I'm just going to leave it like that. So it's going to be x plus 2 times x plus 1. Now, it's still being subtracted. On the right side, I'm going to multiply this by x plus 1 over x plus 1. Up top, I'm left with x plus 1, and on the bottom, I'm going to have the same thing as I did with the blue. Okay, so now I'm just going to subtract the tops and leave the bottoms the exact same. So x minus x, because there's a minus sign in between, cancels off. 2 minus 1 is how I get the 1 up top, and on the bottom, I just have that x plus 2 times x plus 1, and I didn't have to FOIL that out. Okay? All right, number 18. Number 18 is real tricky because we're subtracting and adding these fractions, but none of the bottoms of these fractions match, so we have to make them all match. Well, what do you want to make them, be so that they all match? Well, one of them's a squared, one of them has just a b squared, and the other one has a and b. So I think when we're all done with this, all the bottoms are going to be a squared times b squared. So to make that happen, with the first fraction, we're going to do everything times b squared because it already has the a squared part. The middle, we're going to do ab times the top and bottom because that'll give me my a squared and my b squared on bottom. And then the right fraction, we're going to multiply the top and bottom by a squared because that's all it's missing on bottom. So if you do that, you'll get 2b squared over a squared b squared minus 3ab over a squared b squared, and then plus 4a squared over a squared b squared. So now all the bottoms are the same, so you can just combine the tops. So on the top, we can't add any of those together. We can't subtract any of those because they have to have the same exact variables. So you're just going to write what you have. 2b squared minus 3ab plus 4a squared. There's nothing to do there. There's no reduction. And some people here are going to get real tempted to start canceling off b squareds and a squareds from the top and bottom, but you can't do that because they're being added and subtracted up top. If everything was being multiplied, you could do that, but you can't. Okay, so that is it for worksheet 2B. So if you should have any questions on anything I did, feel free to email me. But like I said, it's a lot of factoring and then just reduction. So good luck with that. And like I said, let me know if you have any questions. Thanks.